Hey everybody, and welcome back to 5-Minute Sickle Cell Lessons. My name is Marissa Gores. I am your 5th generation sickle cell patient and patient advocate. Welcome to lesson number 12. Today we are talking about the various genotypes of sickle cell. Now, a lot of people are like, what are genotypes? What do you mean variations? Well, in sickle cell disease is a collection of abnormal hemoglobins, all that contain the mutant S hemoglobin or sickle hemoglobin. And there are over 40 different types of sickle cell in the world. So there's over 40 different types of these disorders that fall under this umbrella of disease. If there's a scientist out there that would like to simplify that explanation or explain it better, please do so. So let's start off first. You have sickle cell trait. Okay, in order to have sickle cell of any kind back here, you must have two parents with sickle cell trait. So you must have two parents that carry the mutant S gene. Okay, and a lot of times you will see sickle cell trait represented as AS. So if you get two people together, both are AS, and they have kids, every pregnancy, they have a 50% chance of producing a child with sickle cell trait, a 25% chance of producing a child with disease, and a 25% chance of producing a child that has neither the trait nor the disease. Obviously, we will want to shoot for the AA, which is neither the trait nor the disease. Then you have SS. Now, sickle cell SS, which is what I have, means that you inherited the mutant S gene from both parents. You have no, other normal hemoglobin running around in your body. Nope, it's all sickle cell. And ultimately, sickle cell SS is characterized by frequent pain episodes, both chronic and acute crises. We have a lot of joint problems. We have a lot of problems just with our organs, respiratory issues. You will see a lot of hospitalization, and it's not fun, but hey, it is what it is. Then you have sickle cell SC. Now, SC, the percentage of hemoglobin S you have in the body is 50%. Okay, so what that means is that the percentage of fetal hemoglobin to adult hemoglobin in the body is 1 to 10%. And they say the sickle cell SC has about half of the rate of complications as SS, but truthfully, all of it sucks. We are not comparing which sickle cell is better over here. All of it sucks. Sickle cell SC has the same problems as SS, except that they seem to have less hospitalization. So when they are hospitalized, their problems are far more complicated than those with SS. They also have a higher probability of renopathy, and that's basically when you have just sickling in your eye. Because remember, there's 60,000 miles of blood vessels in the body, and we are sickling all day, every day. So retinopathy occurs when the sickling in your eye just damages those vessels so much that it begins to interfere with your vision. So it's very important that we see our eye doctors probably as much as we see, our dentist and our hematologist and all that good stuff. Then you have your sickle cell beta thalassemia plus and beta thalassemia negative. Now, sickle beta thal negative has 100% of SS. And just like sickle cell SS, um, they have the pain problems and the immunity issues, the bone problems, and whatever. It is, and I quote, often difficult to distinguish sickle cell beta thal negative from sickle cell SS without genetic or family studies, but an indicator is the elevated HbA2 with hypochromic microcytic red cells in the absence of transfusion. Uh, Basically, you are going to need a microscope to figure out the difference if one is SS or sickle beta thal. Then you have sickle beta thal plus, which sees a 95 to 60% of a hemoglobin mutant S. It is similar to sickle cell SC, but the phenotype itself depends in part on the regular hemoglobin A levels that vary by the thalassemia mutation. So, whereas sickle cell beta thal plus is more about the variation or the mutation of thalassemia, sickle cell beta thal negative is about the mutation of the sickle gene. Hope that makes sense. Those are the ones that we really deal with a lot more here in the States and I believe in the Western Hemisphere. But as you can see behind me, there's still some to go. So we have sickle cell SD, which is referred to as the Punjab phenotype. The percentage of hemoglobin S is 25 to 60%. It can be similar to sickle cell SS, but phenotype hemoglobin D is not separated by electrophoresis. So you cannot use electrophoresis to separate sickle cell, the hemoglobin D from the rest of the blood cells. This is part one. We will be carrying on to part two next.